Welcome everyone to the National Road Research Alliance. This is where we have a joint team meeting. And the idea here is to highlight projects that may be a broad appeal to a number of us a part of NRRA. So again, welcome to this meeting. This will go till, it's an hour and a half. We'll be going through what Lauren kind of outlined on the agenda that's in the chat. So if you look at the chat, you can see the agenda, but the agenda basically is I'm going to give you a couple minutes of NRRA general stuff, the rigid group, then the PM, the ICT, the Geotech, then the Flex. So with that said, again, welcome and thank you for your participation today. Just because kind of go through a little bit what the executive committee just had a meeting this morning. So I was going to paraphrase what we talked about. But we welcomed each other. We talked about the membership that we have. We talked about some of our highlights. Our meeting before this was in April. And really we talked about phase 3 and what's going on. And I'll share a little bit on that. Phase 2 and how we're closing out phase 1 and 2 and how that closeout's affecting some of the projects that we funded in phase 2 that we're trying to get done and get them going probably by January at least. If that's the fallback we go to, is we'll fund those projects come up into phase 3 because there's a closeout process. I'm not going to get into it too much, but Federal Highway needs so much time and MnDOT to close projects out, and we weren't following those criteria for NRRA 1 and 2, but they want us to start following that better. So it's the reason some of the contracts, and I'll talk about some of the meetings and things like that. But with that said, phase 3, many of the states have now put in for that. I know a number of other states are still in the process of doing it. What you can see from this is what pooled fund is pooledfund.org has a place where you put solicitations. Then states show their interest by pooling commitments. And you can see that we've required 2 million and we've gotten 2.9 million. So MnDOT's in the process right now. We've met our minimum requirement. They're in the process of setting up phase 3 NRRA. So it's a viable project when we get started. With that said, that's some of the projects that we weren't started or we're having difficulty starting in phase 2. If we don't get them started in phase 2, they'll be started early in phase 1 this January. A long story short, we just have to go through a closeout process and kind of had a little delay in some of those things. Another thing to mention about the teams met, and also the executive committee agreed with them, is, talking about the time commitment it takes for NRRA. Do we need to make any changes or not? But I guess we've kind of established that we'll keep doing quarterly meetings, but we'll have technical teams. We'll have kind of the normal technical meetings 4 times a year, or solo meetings, and we'll do the quarterly joint meetings 4 times a year. And then we'll kind of have 4 open months that either could be solo meetings if needed, or they could be let go. Sometimes we hit TRB and other types of times that it gets busy, or during the conference. So that gives some flexibility to the technical teams going into phase 3. The TAPs seem to be really well attended. Thank you for all your participation in all the TAPs for the projects that take place. Quarterly meetings still for the executive committee are as needed, and we'll continue with the research pays off. But just a note, if you have ideas or thoughts on kind of like how we do the meetings and things like that, let us know. We also talked about phase 3 in the general budget, meaning that you can kind of see how these are for 5-year projects for phase 1, 2, and 3. And just kind of look at the percentages. And I guess you can see MnDOT and others has some put additional funds into areas. I'll get to you in a second, Tom. And
you're not sharing anything. That's why I'm raising my hand. Sorry.
Oh, well. Yeah, I call you guys friends. All right. I'm sorry. So here I just went through this solicitation. You can see who's funded it so far. Again, starting up hopefully by January 1st. Talk about the meetings and having some flexibility with that, having solo meetings, joint meetings, and open months. Then talked about the budget for phase 3. And you can see how phase 1, phase 2 shook out. That's TPF 341 and TPF 466. The things that we've kind of talked about adding, you can see there is putting a little bit more money into travel, but having a construction. So we had some funds to do construction at MnRoad. We have had some difficulty doing stuff on the low volume road. We've had money on the main line. But this would help us kind of allow us to work with the NRRA teams to not only do research contracts, but also help with construction. So that's something that has been approved by executive committee. And also the next pooled fund also has where states can put money, extra money in for tech transfer. So we're going to have kind of a tech transfer area there too. And that's where the different teams can kind of put their heads together and say, well, what other things do we need to get this implemented in our state? And that could be doing demos, it could be doing lots of different things. So we just kind of how the money is going to be set up. Again, probably look at the percentages more than anything. That's how we're kind of moving into phase 3. And we'll kind of work out some of those details as we go. But this is the basic outline. The last thing I was going to add was related to construction. We had set a deadline for December of 2025 for next year's construction or getting your ideas in. This allows us to do contracting, to do different things, so we're not rushing to try to get things put together. We had a successful fall where Michael Vrtis and Jacob Calvert and all the people here at MnRoad did a nice job pulling together some different additives on the low volume road, along with a fabric interlayer that we pretty much were able to do kind of a reflective cracking challenge on the low volume road this fall, where the old Rejuvenator test sections were spray rejuvenators. So, but we're looking for ideas for next year. Again, the opportunities on the low volume road for that should say 2026. Got that type drawing, but then 2027, the low volume road and the main line will be opened up for ideas or construction. So with that, that's what I just wanted to mention real quick. I don't want to take too much time because there's some good stuff to be shared through the teams. Anything else, Tom, you want to add since you raised your hand a little while ago?
Nope.
Okay. Well, with that, we will be moving on to the Rigid team. So, Mr. Rigid, go ahead, Tom.
All right. Let's see, is that sharing?
Yes.
Okay. Put it in presentation mode here. Okay. All right. Thank you for the opportunity to update you on some of the activities going on in the Rigid team. And you'll see photos here of 2 sections that have, as you can see, were pretty rough for the driver to get across. So to keep them in service, they got a nice warm blanket of asphalt last week. So they're still hiding underneath there, but nevertheless, then we'll keep monitoring them. But there's an asphalt overlay to kind of smooth things over to keep the truck rolling again until we can maybe replace them in the future. Just to revisit on the current MnRoad concrete test sections, right now we have 27 active on the main line and 24 on the low volume. Although, as I said, now 3 of those have been overlaid with asphalt.
Hey, Tom.
And
you're not in presentation mode.
Oh, no.
I forgot to add some why Tom's doing this. I want
go
to
ahead.
thank Caterpillar too for the asphalt paving and the different companies that we worked with for paving those test sections. You know what? We could go to the PM if you wanted.
Yeah, why don't you do that? And let me get
okay,
my
let's
system.
go to the.
Sorry about that.
Let's go to the PM.
Yeah.
All right. Hi, everybody. Joel Ulring here with the PM team. Tyler Hunt wasn't able to make it today, so I'm filling in for him. We don't have a lot of information to share what's been going on, but we have our ongoing projects. The main three at this point are our hot rubber seal coating, is going on, and we got the materials-based methods to improve rumble strip durability and the use of recycled materials and pavement preservation. So those are ongoing, but our main topic today I wanted to share, Michael Vrtis is going to present on the spray rejuvenator study that's been going on, and that report I believe is now completed and out. So Michael, I'm going to turn the presentation over to you.
All right, we'll see if I have any better luck than Tom. Are you able to see NRRA PM update on spray rejuvenator project?
And,
all right.
Yes.
And you're in presentation mode. Good.
All right. Yeah, Tom bought me some time to practice. So thanks, Tom. Big update on the spray rejuvenator project is the project is complete. The sections have been removed from the low volume road. So we milled them out about a month ago with Caterpillar. We'll talk more about that construction effort in the flexible team. Really wanted to thank all 12 product participants in the study. For those that weren't around in 2020 and 2021 when we kicked this off, we really just put out the open call for anything that fell into the spray rejuvenator category. We did not do any pre-screening. We did not want to get into splitting hairs of what is a product or what is this product, just overall blanket. So the companies put themselves out there, applied the products to 2 sections at Min Road with different host binder grades, and then a section in St. Michael, Minnesota, about 20 minutes away. And that's what I have pictured here. One of my favorite pictures from the project, I call it the checkerboard, but you can see the different treatments every 500 feet going back down the road. Good visual side-by-side comparisons with controls built in. So what have we done with this project reporting wise? So Michigan State was contracted through the Minnesota Local Road Research Board. Their final report is in the final publishing now through the University of Minnesota, who does MnDOT's publishing report publishing. So I'm expecting that one within the next couple weeks. And then NCAT was contracted through the NRRA. And NCAT was solely focused on extracted and recovered binder testing. That was led by Dr. Hoegh, the kind of chemistry expert that they have there, as well as she has a lot of good experience with spray-on rejuvenators and is working on the ongoing NCHRP effort for spray-on rejuvenators. They submitted their final report this summer. It's currently under TAP review, and we are closing out the project, so hoping to have that one published and publicly available within the next month or so, maybe a little bit longer on that timeline. In the meantime, though, Hoegh and the NCAT team has put together a summary for the NCAT newsletter that is either published the end of September or beginning of October. I did not find a link for it as I was looking online now. But when we get it, we'll send it out with the notes or in the team. It does a really, really nice job of summarizing all the work that they did. And from the 120-page final report that I got and distilling it down into just a like 2 or 3 pager with these kind of bolded takeaways here that I'll go through in this meeting. And really good kind of real world applications for how to move forward based off of these results. So we asked Hoegh, she was unable to present today, so I'm kind of covering it for her. Any questions I'll try to help with, but might end up pointing you to NCAT or Hoegh. Findings that you can use: effectiveness was not product specific, but was product specific, not category driven. By that, what we mean is bio products and petroleum-based products did not have a blanket one was better than the other. It was really specific products, not the category or source. Monitor application by residual oil mass. That was one of the strongest correlations they found. The more product that was put down in these treatments, the more benefit they were able to pick up in the resulting lab testing. Expect an early friction drop and plan for it. We had a relatively healthy friction number on all of our roads. We did see a drop, but it was still in a safe range. So if you have friction, a roadway with a already friction concern, these are not the treatments that you would be using. Chemistry and rheology together tell the full story. Independently, one or the other can be a little misleading. And then binder type influences sensitivity to the treatment. This was one of the big things we learned for us here at MnDOT. We have a 5828 unmodified binder and then a 58-34 polymer modified binder. Those are the two common binder grades here in Minnesota. We learned that these treatments are a lot more effective on the unmodified 5828. Binder types and I just covered that one. And then product chemistry can confound chemical matrices. I'll talk more about that on the next slide. And then short-term aging is a confirmation spec, not the end result. How to use on your next project: specify residual oil mass, use two-stage acceptance, plan for safety, match product to site, and then back to the chemical indices. Interpret with awareness of solvent effects, avoid overemphasis on serofractionation. Serofractionation, the saturates, aromatics, asphaltenes, and resins, uses a solvent to break up the asphalt into those individual components. That solvent has an influence, especially with bio-based binders, on the breakdown and how each of those individual components are sorted out. So use complementary indices or indicators like FTIR. And then I really liked the bottom line summary, and I apologize for reading this word for word, but I think it's well said. Spray-on rejuvenators can extend surface life, but success depends on matching product and retained dose to the pavement and verifying performance over time. Focus specs on residual oil mass, plan for early friction management, and evaluate chemical and rheological behavior together. With these steps, agencies can turn a promising treatment into a reliable preservation tool. So again, thanks to NCAT and Hoegh for the work on this project and all the products participants, and I'll turn it back over to Joel.
Thank you very much, Michael. I really appreciate you stepping forward and presenting that information since Raquel couldn't join us. I really don't have a lot of other information to share, but I don't know if it's appropriate to take any questions on this at this point, Michael, or just let people email us and go from there. Any thoughts?
I'm fine if there's short questions now. Otherwise, I think any longer discussions we should hold.
Sure, but we do have time for a couple of short questions if anybody has any. All right, hearing none, we'll move on. But like I said, I really didn't have much else to share today. But again, the PM meeting meets the first Wednesday at 2:30 in the afternoon of each month. So join us if you're interested. With that, I guess I'll turn it back over to Ben, and hopefully Tom's ready to go.
Well, thanks, Joel. Let's see if Tom has figured things out. You want to try it again, Tom?
Sure.
So we change up the schedule a little bit as Tom gets this booted up. We did the PM before the rigid. Lauren has a schedule on.
Is that better yet?
Yep. Looks good.
In presentation. Oh, it's ready to go?
It's narrow presentation mode, but it's presentation mode.
Oh,
it's good.
Okay. Okay. All right. I'll resume where I left off then. Okay, back to quantifying the test sections. Again, we have a mixture of pavement types: joint planted on gravel base. We have some thin fiber reinforced on gravel. Again, those have now been overlaid with asphalt to get the truck over them. And we have some ultra thin fiber concrete on concrete, which I featured on the last time we had a joint meeting. So the focus on the main line now is predominantly about lower carbon content concrete pavements, and we have 4 active studies going on, and I'm not going to go through them, but you can see them listed there. And what those are doing is essentially studying the performance
Tom, it's not
kind of-
advancing. I see your rigid team activities first slide. Why don't you just put it in regular mode and just go through the slides? It's not perfect, but at least
it's
doesn't.
not cooperating with
It's
like
not
multiple
advancing.
screens. Yeah.
So maybe just try it in PowerPoint mode.
Yeah.
Get through it.
Just escape from the presentation mode and run with the regular mode. We'll
Yep.
see it.
Yeah. Well, it's giving you fits, isn't it?
It is, yeah. I'm sorry.
Yeah.
I mean,
No, it happens.
I don't know why it's happening now.
Why don't we go on to the ICT?
Yep.
Kyle,
Go
if
ahead.
you could take it from there, then I'll bring the rigid one up.
All right. Thanks for the opportunity here. Let me share my screen and we'll hope for the best. Okay.
Oh boy.
All right.
Right.
Do we see a title slide? October quarterly joint NRRA meeting ICT update.
Yes.
Awesome. All right. So I guess before I got into the meat and potatoes of the update here, did want to put a plug in. November 18th is Veta Enhancements update presented by George Chang and Rebecca Embacher. So that is going to be a lot of good information shared there. So put that in your calendars.
Rescheduled.
What's that?
Kyle, that's been rescheduled to October 21st.
Oh, even better. You get to see it sooner. Thank you, George, for correcting me as always. So,
we swap.
Let me put this here just so there's no no confusion about that. So, all right. So October 21st, even sooner, you get to see and hear about the Veta enhancements. Thanks for that, George. And that's just an example of how quick on the draw George is. So you can really look forward to that, I'm sure. So also, we have just a really brief update with the two projects we have going on here. Soheil, as always, has agreed to give us a little bit of a snapshot of where we're at with those two projects. Do you want to take it from here, Soheil?
Sure. Good afternoon, everybody. We have two ongoing projects in the middle of the progress. I guess the first one is the effective use of TST for network level and project level based, which EOP is the program manager from the technical liaison from the Minnesota DOT. In this one, we are just trying to find the best uses of the TST, given the cost of the data collection and tremendous benefit that you get from having the continuous data. What's the low-hanging fruit first, and then what are the best way we can improve the interpretation given the state of the device. Right now, we are focusing on temperature correction, and we have completed that, and hopefully you would hear about it in the TRB. It just got accepted for presentation at the TRB. And what we are focusing right now is to improve the interpretation of the TST, if you're familiar with it, how to go from what measured by the device with what we want, which is a deflection. That's an area that needs improvement, and we are making good progress. And hopefully, next time, maybe we can present it in detail. The second one, I guess that's brief enough, right?
Yeah, oh yeah, that's perfect.
Okay. The second one is establishing the applicability of NDT methods. In this one, we are focusing on three technologies that well known, GPR, FWD, and TSD. and we want to see how we can use them best for the project level evaluation that we have. What is the most robust way of using it? What's the limits that you should expect in terms of the distresses and so on and so forth? And we are basically focusing on the structural problems like rotting and cracking, and then some of the defects like stripping, debonding, delamination. With that one, we have Isaac Zuniga is just doing an incredible job on that one. We are just basically doing sensitivity analysis of what's the minimum damage you should have before you could detect it with the 3D technologies. And then now we are focusing a lot on the delamination and debonding. What's the best way to find them, and what's the threshold that you can find them, at what state? And again, hopefully that will be two meetings from now. We're going to have really nice results, to show you. Isaac is doing an incredible job. In this one, we have Jacob and we have, of course, Kyle. They are guiding us through the process. Again, we are having a lot of fun with these two projects. Thanks for NRRA to funding it too.
Yes, thank you very much, Soheil. We're having fun with those projects on our side too. Before we get to, I did want to do an actual semi-technical update for the group. I did want to brief us on some of the recent presentations we've had at the monthly meeting. We did had some pretty successful initial trials of the roller-mounted DPS for, I guess, a little bit more real-time compaction assessment. That's been an exciting development in the ICT world, and also had a nice presentation on a project we're co-sponsoring with the Rigid team. Dr. Ken Mazer gave us an update on some of the automated 3D GPR analysis for concrete pavement evaluation. But the main thing I wanted to highlight for this group today, we have a new member, and we're going to call it the new member spotlight. So William Tripp Baker from Turner Fairbank, FHWA contractor, emailed Lauren the other day and kind of explained some of the stuff that he's been working on, and I started to dig into it and wanted to learn more, and because it's a lot of the kind of cutting edge or emerging technologies that do affect our intelligent construction, and figured what better venue than to allow us to get to know Tripp a little bit better, and then also I think a lot of us will learn about some things that are available now that that maybe we didn't know in the past. So Tripp, I don't know if you're with us here today and able to share some of your emerging technologies.
Yep, I'm here, Kyle. Can you hear me?
Yes.
Cool. So I can go ahead and sorry, let me share my screen first. And then can everyone see my presentation?
Yes.
Cool. So again, thank you everyone for the opportunity. So again, I'm William Tripp Baker, so nickname is Tripp. I'm currently doing a postdoc through the National Academy's NRC research program at Federal Highways Turner Fairbank Highway Research Center under the advisement of Dr. Jennifer Nix. So just a quick background. So I recently finished my PhD last spring at the University of Delaware with a main focus on, continuous compaction control or intelligent compaction technologies. Very broadly, research portfolio deals with, again, automation and construction, whether that's CCC technologies or UAV surveying, which I'll sort of talk about in this presentation, but do have some experience with, dynamic and long-term monitoring instrumentation, along with sensor fabrication. And then in terms of like other service activities I've been involved with, while in grad school, I was a part of the GeoCongress, Student Leadership Council, both as a chair and the GeoCongress planning chair. And then I'm currently on GeoCongress's EDS committee, where I've been a session chair for 2 upcoming conferences. So today I'm just going to talk about one of the studies from my dissertation. It was looking at emerging technologies for assessing soil lip thickness during the compaction process. It's building off of a previous study that my PhD advisor, Dr. Chris Meehan, did back earlier in the early 2010s when he was first looking at CCC technology. So I just want to give credit to Chris, where essentially the study that we did during my dissertation is building off of sort of the idea that he had back in 2013. So if we just look at from an earthwork QA/QC perspective, lip thickness control is pretty much in all specifications. So whether it's method-based or end product-based, and it's really to help optimize the compaction process. So very generally, if lips are too thin, obviously we're reducing the efficiency of the construction process. And then if lifts are being placed too thick, well, then we could run into issues of, under compaction during the compaction process. So my PhD advisor sort of during his initial CCC studies back, in the early 2010s, he sort of postulated the idea, well, we are getting GPS measurements from the roller. And obviously most of the literature has focused on relating the machine response, so whether it's CMV, KS, eVibe, to, localized stiffness measurements, LWD, FWD, so on and so forth. He was sort of saying, why not try to augment this technology and also use this technology to, look at lift thickness, but in a more continuous sense, over the entire project area. So essentially the study that we were looking at was sort of validating the accuracy of CCC technology for lift nicks, but also looking at other emerging technologies as well. So project site, this took place along construction of US 301 in Middletown, Delaware. So we were looking at a specific section. And so then we constructed a test pad along a stockpile where the contractor was placing fill. So general study layout, essentially we had 2 test grids. Each grid had 41 of, which I'll talk about in the next slide, of these discs. So these are steel discs that are used by the MIT scan lip thickness scanner. So obviously you see that device for to replace pavement core applications, but essentially we were using this to also assess soil lip thickness. So essentially we had 82 control points where after we place a lift on top of all these discs, we could verify the thickness. And so the 2 grids were to look at 2, nominal lift thicknesses, whether it was a foot or 8 inches. And so again, so during construction, all these discs were, again, staked out because they were already programmed into the GPS. They were nailed, and then all the discs were then surveyed with, again, traditional RTK GPS and then total station. And so just some pictures of the construction process. So again, all the discs were laid out, and then obviously contractor put down fill and then graded everything. And then once everything was graded and then compacted, everything was then resurveyed with all the survey equipment as well. So if we sort of look at, again, the goal was to look at a lot of different technologies, both new and old. So if we look at sort of quote unquote traditional survey, we had RTK GPS, we had total station, and then obviously the MIT scan lip thickness scanner, and then obviously some more emerging technologies. We had obviously the GPS from a compaction roller that was integrated with a CCC kit, and then we also flew a drone and then used photogrammetry to then back out those photos to get and then your 3D survey data. So obviously with both the roller and the drone, the base before they put down the lift was obviously surveyed before we laid out all the discs. So with the roller, we just did a static proof roll because obviously we didn't want the vibrations to affect, the readings from the GPS. And then same thing with the drone. It flew before we placed the disc, and then after the lift was placed and then compacted. And so we're looking at all these different technologies, but obviously with this type of study, and so the analogy would be if you did this study along a pavement field, obviously you would truth everything against pavement cores. So in the context of soil lift thickness, essentially to sort of truth everything, which you'll see on the next slides, is that essentially we dug down to each of these 82 locations. And because these discs were, they had a center nail, essentially we physically measured the thickness along all 82 of these locations just so that, we could verify the thickness, or so that we could essentially truth everything to one standard measurement. In context of the survey data you're getting from both the compaction roller, which you see on the top, and then from the drone, which you see on the bottom, obviously the data is much more spatially continuous. And so with this type of analysis, obviously to verify accuracy, we only really care about, the thicknesses at each of those 82 disc locations. And so looking at the spatial patterns, there's not always a single measurement right on a disc location. So obviously to estimate the elevation measurements at those point of interest, we looked at 3 different levels of essentially spatial interpolation. So nearest neighbor, inverse distance weighting, and then kriging to, again, estimate the elevations both before and after the lift were placed so that we could back out thickness. So if I just kind of go through the results relatively quickly. So this is all sort of your traditional survey measurements. So RTK GPS on the left, total station in the center, and then MIT scanner on the far right. Essentially, the MIT was the most accurate out of the 3. The only limitation was, you'll notice on the axes of that particular plot, you're only able to measure thicknesses beyond roughly 1.2 times the disc diameter, because what ended up happening during the construction process was that there were locations where thicker lifts were placed just to create a level platform. So we're actually able to measure thicknesses as high as you can see, roughly 66 centimeters. If we look at sort of the results from the CCC roller, really the biggest takeaway is that, in terms of accuracy, if you just look at mean absolute error, the GPS from the roller is influenced by your spatial interpolation function. So essentially, and ironically for this data, IDW was slightly more accurate than kriging, but essentially with respect to, say, nearest neighbor or looking at a single point, essentially you want to look at points in an average sense or looking at a collection of points in order to get a better estimate of thickness. And then if we look at, so again, UAV survey in conjunction with photogrammetry, it was not influenced by the interpolation function. That's probably because, you're getting a much denser point cloud relative to the GPS from your roller. And again, it was also more accurate than the GPS from your roller. This sort of looks at everything, the accuracy of each device sort of all together. So you can obviously see that, the MIT scan 3 was obviously the most accurate out of, all the methods that we looked at. And then you can also see how, the UAV measurements are relatively consistent across interpolation functions. And again, this sort of summarizes everything. Really, the biggest thing you can look at is just the rankings on the left. So obviously, MIT scan T3 performed the best, followed by total station, and then actually UAV surveying, in conjunction with kriging, was the 3rd best method in terms of assessing lift thickness. But again, one of the advantages of collecting, survey information on a more continuous basis, whether it's through a compaction roller or a UAV, is that you can now sort of create these visual spatial heat maps of lift thickness. And so really the takeaway from this plot is, rollers on the left, and then sort of the sophistication of your interpolation function increases as you go down each plot. But essentially, looking at these plots, yes, there's variation, but they're all sort of telling you the same story. And so more importantly, instead of looking at these plots as like heat maps, you can sort of look at them as sort of like a QA/QC heat map, where depending on the project, if you sort of, and depending on your tolerances, you can look at areas that sort of failed because they're too thin of a lift after compaction, or areas that are too thick after compaction. But generally what I'm trying to show, again, rollers on the left, UAVs on the right, is that essentially they're telling the same story. And then, the argument would be within a production environment, the same decision is going to be made regardless of whether it's from the GPS from a roller or from a UAV survey. And then, so again, just to summarize, really on a point-by-point basis, the MIT scan T3 was pretty accurate for assessing soil lift thickness on a more continuous basis. UAV was, performed better than the GPS from your CCC roller. However, qualitatively, again, looking at things in terms of heat maps and QA/QC heat maps, the CCC roller and the UAV were consistent with one another. And so the advantage would be obviously generating these type of maps is probably more real time with, a CCC roller relative to a UAV based survey, because obviously after surveying, you have to post process it, which obviously takes more time. So again, essentially they're telling the same story. And again, just want to acknowledge that, again, with any type of field study like this, there are a lot of people involved. And so I do, again, without these people, this project would not have been possible. And yeah, so again, thank you everyone for your time.
Yeah, thanks a lot, Trip. We do have 1 minute for questions, or a question here, and just a brief note that it actually sounds like it is November 18th for the Veta Enhancements update, and George owes Lauren a wine, although it's got to be $5 or less, so proceed at your own risk, Lauren. Bernard, you have your hand up for a question.
Yes, this presentation very interesting. So I was wondering, did you at any time consider using the Kullback-Leibler divergence analysis to quantify first of all, the technology within itself, and then the technologies compared, using the Kullback-Leibler divergence? This kind of thing lends itself to it, so you have a numerical value. Did you consider that at all?
No, because I've never actually heard of that type of analysis.
Okay. All right. It would be nice for us to do it, so we can talk further after this.
All right. Well, so Trip, if you don't mind, maybe put your information in the chat, and if people have more detailed questions and discussion, you guys can have fun with that over email and whatnot. So, but with that, we will cede our time to the next group, Ben.
All right. Well, thank you, Trip, for that presentation. Tom, just say yep, and I'll change.
All right, you're in control now. All right, slide 3. It's all on you now.
Can you see the slide? Did it change? See the main line, low volume road?
Yes.
Okay.
Great.
Now this is where you talk,
next,
Tom. Now.
Yes.
Next slide.
Next slide. All right. So yeah, I was saying we have 24 sections we're monitoring. Next slide. All right. Current status. So of the three, the set of 16 built in 2022, the research teams are working now in their 3rd year performance report, and that will pretty much wrap up those projects. But we do have funding secured. Again, Ben was talking about, we put in a request to extend the performance monitoring period, but those projects will have to be started next year, and then we'll go for probably another 3 years. And because not really seeing a whole bunch, and you have to, some of these materials types studies, you need to obviously monitor them for a longer period before you might see any differences. The sections built in 2024, that team has now completed their first task, and they're working on some of their other tasks like the construction testing analysis, the constructability evaluation, and then they're getting to their point of working on their first year performance report. Next slide, please. Condition of the sections, so far they're holding up under, right now we have continuous interstate traffic since it's being used for diversion of constructing 3 lanes parallel. So we have not had an opportunity to go out there, and we've been exploring the possibility of trying to get a lane closure this fall. Again, we hope we can at least get even a day or two or something out there to peek at things, take a few physical measurements. Right now, it's been mostly whatever we can collect within the stream of traffic. Next slide, please. And then last fall, we constructed a couple of panels on test section 37. Now it's called 2437. That's with BCSA cement, placed in very cold temperature. And embedded within is a little sub-study that MnDOT's been looking at, and that's the use of 3/4 inch diameter dowel bars and seeing how those can be applied. Next slide. 2437, I think Bernard has completed a construction report on that alone, a material loan, and then there's another construction report dealing with the 3/4 inch diameter dowel bars, which we not only have them in 2 joints at Minroad, we also have 6 joints on another project on Interstate 35 near Hinckley, Minnesota. So those are being monitored kind of as a MnDOT project. Next slide. Other active NRRA projects, one that me and my colleague have been working on, the use of early loading to increase joint deployment. So again, this is about the observation that if you're building a concrete overlay on asphalt, sometimes we're sawing them at every 6 feet, and we're finding that they're not deploying for a while. And we thought, some contractors came up with the idea, what if we run like a water truck over it and see if that increases it? So that particular study, we're now in the 2nd year performance report for the particular cells at Minroad. There's also some other sites around Minnesota that we've been following. The other one is concrete overlay test sections using PEM and diamond grinding. So this would be repairs to concrete overlays, and then also diamond grinding in the case that we have some faulted joints. So we're evaluating the performance of, again, the Minroad test sections. Some of them we've lost now because we reconstructed them in 2024. However, we have some statewide projects that we're continuing to monitor. Got mentioned before that there's this automated 3D GPR analysis that we're joint teaming with the ICT team. And so you've had an update on where those are at. They're getting close to some software development, I believe, and in November, they're hopefully going to reveal that. Next slide. We also have a project from 2024, new test sections dealing with microspheres in lieu of this for air and training concrete. So we're using these microspheres. That project is moving along. The first 3 tasks have been completed: the literature review, mixed design development, and assistance with construction. And that team should be working on the 1st year performance report. And I guess there's going to be a TAP meeting in January to report on what they're finding. We also recently completed the 2024 Minroad concrete construction activities report. So essentially reporting what got put down. So that's not available online. And then if Maria's on the call, she can kind of give us an update on where we're at with the mixed design and construction assistant project that Larry Sutter has been helping us with.
Thanks, Tom. This one is not online, nor is there a link to the project, but we'll work to rectify that. So Larry is working on finalizing the report. He's reached back out to the suppliers to see if we can get EPD information from them, and just a little bit more about the chemical composition of their cementitious blends that they produced for us. And so the project was supposed to be done at the end of June, so I'm working on that one, but the goal is for it to be done by the end of the year, and maybe he can present on it at the NRRA next year. We'll see. So
Great. Thank you for that
thanks.
update.
Yep.
Next slide. So again, if you're interested, go to our team page for projects, and most of our projects are listed. We always struggle to kind of keep updated, but you can find out a lot of what I've revealed today. Next slide, please. And then again, Ben has put out the December 1st deadline to think about some test sections on the low volume road next year. So that's going to have to be some pretty rapid turnaround. So I will be contacting people on the rigid team for ideas. And as I always say, MnDOT, especially the low volume, is think boldly, because we can somewhat afford to fail, but anyway, you don't have to be as nervous as putting it out on the interstate. And that should wrap up my update. Oh,
One more.
I guess not.
Extended Tom.
All right, so these are MnDOT, just sharing some MnDOT research initiatives. Myself and my colleague Mike Wallace have been going out and revisiting concrete overlay and asphalt projects in Minnesota. It's been a while. I think 2018 we put our last report together, and the number of sections have doubled. So our counties are building, several projects per year. So they've kind of stacked up. So we're kind of revisiting and very much focusing on some of those very early ones. A lot of them built in like about 2009 to 2011. So they got some years on them, so we're very interested to see how they're holding up. And then Mike Wallace is working on developing a video and user's guide for the operation of the Mira ultrasonic tomography testing device. I don't know that too many people have those, but they're great devices, but they're a little challenging to operate. So hopefully this will help users out in the field. You don't have to be such an expert at it and be able to use it. It's a great tool. And then, as I mentioned before, we're monitoring the performance of those test sections with 3/4 inch diameter dowel bars. Now I'm done. If there's any questions, feel free to ask. Yes, Bernard. You have to unmute.
I just pasted in the chat the 3/4 inch dowels report.
Great.
And then the construction report for that particular cell and the low volume road, we had completed it, but there was some proprietary language that needed to be modified. So we kind of recalled the construction report, and we will make those modifications with the manufacturers.
Great, thank you. Any other general questions for the rigid team? All right, thanks, Ben, for bailing me out. I'll have it figured out next time.
No problem. I enjoy helping my friends. So next we have up is the Geotech. Raul, are you ready?
Yes, hello, good afternoon. For the Geotech time, we have an update on the Main Road Flooded Pavement Initiative. So we have one of the TLs providing a presentation. Wasif, are you online?
Yes, I'm here.
All right, I have the presentation open in case yours doesn't work, but hopefully you can share your slides and navigate it.
Sure, I can do that. You want me to go ahead?
Yes, please.
Can you all see my slides?
Yep.
Okay, so good afternoon, everyone. My name is Wasif. I'm a research engineer at Dunn Fairbank Highway Research Center as a contractor. I'm also co-technical liaison for the Simulating Flooded Pavement at MnDOT project, along with Deepak from Caltrans. So we'll just provide some brief update. This is a project still in development. And we are still in the very early stages of this project. So we just wanted to touch some bases on where we are, what we are doing, and why we are doing this. Flooded pavement is not a new phenomena. I'm pretty sure we all have seen these flooded pavements somewhere, sometime in our life. But the problem is it's going to happen even more. The based on the recent reports from the climate change and all, there are these events of flooded pavement are going to occur more frequently. So we'll see more pavements which are flooded during different seasons. And that's a problem because flooded pavements can cause issues in the pavements apart from the safety concerns that are associated with it. Of course, flood pavement can cause road closures and hydroplaning issues, but in the long term, it leads to structural weakening, and base and the sub-base and the subgrade layer can get saturated. And as we know that as these layers get more and more saturated, they start losing their strength and stiffness. So that's why pavements getting flooded is not a good thing for pavement foundation layers. And this also the surface distresses like rutting and stripping and cracking can be accelerated because of the flooding in a pavement. So ultimately, this all leads to high maintenance costs, accessibility issues in some areas, and especially the rural and low access areas. So yeah, and this issue is particularly more problematic in coastal areas and also the low-lying areas as well. So what are the current practices? So there are different practices used by DOT. Some of them just do like visual inspection and quick surface check to see if the pavement can be opened again after the flooding. Some of them do use LWD and FWD after floods to see if if the road can be reopened again, and does it have enough strength and stiffness after the flooding to be operational. There are also load restrictions that are implemented sometimes in these cases when the pavement is recovering from flooding. So basically, we have a lot of these limitations coming because of the lack of the research. So there is no standardized criteria. When do we call the pavement flooded and when do we call it as recovered? How long does it take for the flooded pavement to recover? There is also a lack of layer specific data. So how long does a particular layer takes to recover, and like base, subbase, and subgrade, and how does it react to saturation? The other issue is the predicting the time to drain and stiffness recovery. So time to drain is basically the time it takes for a layer to get rid of the water. So it can be different, like you want to get rid of 50% of the water in the layer or 100%. So this is concept being used by the federal highway in the past, but it's not really that much implemented by the DOTs during design, during construction. But it is very critical to know that how long does a layer takes to drain a particular amount of water. And then there's the aspect of stiffness. So the longer the moisture going to sit there, the longer the longer it will take for the pavement to recover to its original state, which is the original stiffness it had. So there are support tools such as a flooded payment app that was developed as a part of the MnDOT project. And the app is in the first version, I guess, but it lacks any full scale field data for validation and calibration. So these are some of the reasons why we are trying to address with this project by building this controlled instrumented experiment section at MnDOT. From a recent report also, report titled Payment Resilience by FHWA, they also talked about these gaps and research needs to make the payment more resilient. And they also identified these issues which are associated with the flooded payment. So they identified that there needs to be a better design of the base and sub-base layer to increase structural integrity, especially in areas subject to inundation. We need rapid evaluation and assessment criteria, which is where the time to drain and the recovery of stiffness aspects come into the picture. And how we can improve the design, how we can make the payment more resilient, especially the payments which can be subjected to flooded conditions. So there have been knowledge gaps which were identified very recently regarding the flood is associated with the flooded payment research. So, like I said, we are still developing this projects in the development stage. So we are still trying to figure out what questions we can answer and what questions are related to this problem and how many questions we can answer with this research. Some of the questions we have agreed upon is like, how long should pavement remain closed after flooding? So how basically it connects to how long does it take to recover to its initial stiffness, or whether it can actually recover to its initial stiffness ever, or the damage is kind of permanent. How do different layers, base, sub-base, sub on to saturation? What is the time to drain and stiffness recovery? Is there a particular threshold of flooding duration after which the pavement just cannot recover anymore? The damage is kind of a permanent. What rehabilitation strategy that we can use to make the pavement more flood resilient? Can we use some field measurements like LWD, FWD to identify when the pavement is fully recovered? And also the apps, for example, the recent app developed by from the project, the flooded pavement app. Can we use that app to actually identify when we can open the road again for the traffic? So there is a lack of field data related to this area of research. That's why we need research done in this area. So we are still developing the work plan, drafting the work plan right now. So initially we identified basically 3 phases of the project. So we are basically going to use a stockpile area where we have cell 83 and cell 84, which were used for a study done in 2006 for some husbandry equipment research. So the idea for the phase 1 is basically to construct to basically work using the existing work on the existing section. So we are basically constructing trenches and dikes around existing section to hold water during flooding. We had a long discussion basically how to simulate actual flooding in the pavement, and we all agreed upon having a bottom of flooding, which actually kind of more representative to what happens in the real world. So installing some structural and environmental monitoring sensor, then saturate the pavement ultimately, and conduct some field testing and get data from the sensors and see generate some results from it. Ultimately, in the phase 2 is when we mill and overlay these sections because they are in pretty bad shape right now. So the idea is to mill and overlay these sections with new HMA layer and repeat the same thing. So we flood the section, we apply some loading, and we test them the time to drain and the recovery, stiffness recovery. In the phase 3, eventually the idea is to construct these sections from the scratch and use some new design concept, learning from phase 1 and phase 2, and using some sustainable material so that we can make these pavement more resilient to flooding, and then basically simulate the same full suite of flooding and testing scenarios. So Ben and Jacob's team just started constructing these test sections. So we agreed upon having trenches on both sides of the cells, which are like 1.5 foot wide, and the trenches go into the subgrade so that we can have we can fill them with water and then let the subgrade and the base and the subbase saturate from both sides. Since the flooding can also impact the asphalt layer, the top layer, we decided to stick to at least have 1 inch of water sitting above the asphalt layer, so we can evaluate what effects of flooding would have on the asphalt layer as well. We will use valves and sump to basically control flooding and drainage. And then we are still talking about sensors, what sensors we can put into these sections. Definitely, since this is a study about moisture and the flooding, we definitely going to end up putting some moisture and suction sensors. And we are still discussing about other instrumentation that can go into these section, if not in the phase 1, possibly in the phase 2. But the idea is to instrument it as much as possible, so get as much data as we can. So there are some new sensors we are considering, like Bender element, which basically tells you, gives you a shear modulus and helps you. It can help you basically identify, evaluate how long does it take for the pavement to recover to its own initial stiffness. We are also evaluating what in situ testing we can do as a part of this project, visual testing, FWD, LWD, and same bunch of tests. So we are still developing a work plan to identify which of these tests are most relevant for this project. So this is the existing test section. It is near the stockpile area, as I understand. So it's in the near the stockpile area. We had 2 sections, cell 83, cell 84, which are highlighted in green here. So so they are kind of reconstructing, like modifying these test sections so that we can simulate the flooding scenarios on these test section. So like I said, they are cell 83 and cell 84 used in the past for another research long time ago. So For the phase 1, we are particularly focusing on cell 83 because we are trying to get this constructed as fast as possible and you do some flooding by the next spring. So cell 83 consists of 3.5 inch of asphalt layer with 8 inch of base and a clay subgrade. But ultimately the idea is to use this whole strip, have multiple sections, and to some flooding and all in phase 2 and phase 3. So this is the existing condition of the cell 83 near the stockpile. And this is how we kind of working on construction of the test section. So the leftmost is the cell 83. So we are only utilizing the 200 foot of the roadway of the cell 83. But ultimately the idea is that we will have 3 sections of 200 foot. And we have a 24-inch of 12-foot lane, and then 6 foot of shoulder, and then we dug a foot of trench on both sides, which is we're going to fill with water to simulate some flooding. And then we have berms to prevent this water from going away, so the water sticks inside and goes only inside the pavement rather than going. So yeah, I mean, Jacob can elaborate more on this if you have questions, since he is working on this, taking care of the construction part of this project. So this is the profile of the test section cell 83. So we have lanes, then we have shoulder, and then just right after the shoulder, we have a trench, which is the idea is to fill that trench with water and then simulate the flooding. After the trench, we have a berm to basically prevent the water from going to the sides, so that it kind of travels towards the pavement, not away from it. And like I said in the beginning, we will have valves and valves to control the flooding and drainage. So up to some point, we will flood the pavement so that the layers can saturate completely, and we load it, do some testing. But then ultimately, we want this water to go away to evaluate how long does it take for the stiffness to recover. So these trenches are going to help us do all those things. These are some construction updates. So Jacob and his team has been working hard to get these sections built up, and they have been focusing on set 3 right now. So which is basically 200 foot of section with trenches on each side. And they already excavated trenches for cell 83 and filled it with the drain tile and coarse filter aggregate. We are also putting fabric basically to prevent material intrusion. So, and then another plastic sheeting, 8 mil of plastic sheeting to basically go along the berm to prevent. Basically, the idea is to force water to go inside the pavement and not allow it to go away from the pavement. And then using pipes to basically facilitate with the sensor installation. In 2025, the goal is to get the shaping of the berms around cell 83 done, and then placing the plastic sheeting against the berm, and then covering of plastic sheeting with aggregate material. They are also regrading the ditches, and that's where we're going to install some collection and pump basin, and then regrade of aggregate shoulder of cell 83. And ultimately, the idea is to flood it by spring 2026 to get this section built in 2025, and we would have a strong work plan by then, and then we would be able to flood this in spring 2026. Some of the expected outcome from this project is we would have a defined criteria is when we call the pavement flooded and when do we call it's completely drained, it has recovered. We can quantify time to drain and recovery under different scenario. We can establish some threshold of how much loading is allowed when the pavement is flooded and during and after flooded. And then this section will also help us get some data to validate the NRRA flooded road app. Ultimately, the outcome from this project will help state DOTs on closures of flooded pavement, their recovery, and design and rehabilitation strategies. So these are some references, and that's all I have.
Thank you so much, Wasif and Deepak, for all the work you're doing, leading this effort. Any questions for him? No questions, then I'll give back the floor to Ben.
All right. Well, thank you, Raul. Thank you, Oz. Again, we got to thank Jesse and Troy too that have been doing a lot of the legwork out there in the stockpile area. Our truck driver and laborer here at MnRoad. With that said, the last presentation.
Okay.
You ready to go there, Mr. Flex?
Yeah.
All right, thanks, Curt.
Sure. I'll share my screen here and get to the presentation here. We'll get into the slideshow mode here. So welcome everybody and thanks for attending. So we've got a pretty good update here, I believe. Start with the flexible team has got about 26 projects currently, and about half of them are listed. You know, they're all listed on the website, and about half of them are completed now. And we've also got about we got about 4 co-sponsored projects going on as well. We've got about 8 projects that are exclusively flexible team projects. And also we've got some developing projects that are sort of waiting for the green light to get going on. So I just wanted to before we have our highlighted project here today, wanted to mention about the research needs that we're looking for. There's a lot of exciting things that are happening right now on the MnRoad test track on the low volume road with reflective cracking study, low volume reflective cracking study to build upon, expand on what we did in 2022 with the reflective cracking NCAT additive group reflective cracking study challenge. So that kind of brings me into just a shout out for research needs and ideas that we can think up for the low volume road. And it would be nice to maybe the next meeting we have to maybe spend some time and do some brainstorming on how we could come up with some interesting ideas. We've got some ideas there to the left that have been on the shelf for a while, like the thick asphalt sections, the high mod asphalt mixes, and then other things like maybe more uses for the wrap. There's just about everything we're researching now has wrap kind of comes into play with it. So it'd be nice to be able to take what we've already learned from phase 1 and 2 and start to try to implement some of these things, like to try to take it back to the agencies and see what we can put in our wrap so that we can use more of it, like rejuvenators and will warm mix technologies help, and also cold central plant recycling, things like that. It'd be nice to have like an implementation plan to go forward. So I guess that would be my it would be good if we'd get together and do some brainstorming, maybe the next meeting here. And if we have to break out in other sessions, if we have some good ideas, it'd be nice to come up with some costs and things that we can have put on the shelf and be ready to go. So with that, so we're going to highlight one of our flexible team research that we have going. And so the one we're going to highlight today is the validation of loose mix aging procedures with cracking resistance evaluation and balanced mix design. And the presenter is Dr. Fan Yin, Assistant Director at NCAT. And Fan's research focuses on balanced mix design, sustainable pavement materials, and advanced asphalt material characterization. So synopsis of this project is really the overall project seeks to validate loose mix aging for cracking resistance evaluation of asphalt mixtures and balanced mix design. So Fan, if you're ready to go, I'll stop sharing.
Okay, all right, sounds good. Thanks, Curt. Let me share my screen. Okay, let's see if that works. All right, can y'all see my screen okay?
Yes.
Okay, all right, sounds good. Well, good afternoon, everyone. Thank you for joining the NRRA meeting. Great to be on the agenda to talk a little bit about one of the projects we're doing at NCAT. As Curt introduced, the title of the project that we're working on is the validation of loose mix aging procedures for cracking resistant evaluation in balanced mix design.
I do want to highlight that this is a great collaboration that we have at NCAT with University of New Hampshire and Texas A&M Transportation Institute. It has been great working together as a team. Before I talk, dive deep into kind of like what we did, I just kind of like want to take one step back on why we proposed this research at the beginning of this effort. I think over the last several years, there has been lots of interest and discussions about the balanced mix design, with the cracking being the primary focus of asphalt pavement nowadays. Lots of agencies and industry focus on balanced mix design, try to improve the cracking resistance of the mixtures. As part of that cracking evaluation, we recognize that long-term aging is critical, especially for those cracking distresses that tend to initiate from the surface of the pavement. Two good examples would be top-down cracking and the thermal cracking, okay? So if we look at kind of like where we were, I would say like right before like 2024 last year, AASHTO R30 was really kind of like the guidance from kind of like on the national level regarding how we should handle aging for mechanical testing or performance testing, depending on how you want to call it. The general consensus is on that is that, for routine evaluation, we want to use short-term aging, but for cracking evaluation, we need to look at long-term aging for different reasons. One is that, cracking does not occur right after construction, right? It is, in many cases, occurs several years after the mix is being placed in the field. And we know like aging is really not, the friend of us when we talk about the cracking performance, because after aging, the material become, stiffer, more brittle, gonna lose some relaxation properties, gonna make the material more susceptible. If we look at, the recommendation at that time in AASHTO R35, the recommended procedure was compacted specimen aging for 5 days at 85°C. There has been some challenges associated with that procedure. One is a long duration, 5 days. May not be a big deal like from the mix design phase, but if we try to incorporate that during production, it can be very challenging to accommodate just because of the long duration of that procedure. Another issue is that, because we are doing the aging on the compacted specimens, we make the specimen susceptible to like aging gradient within the specimen. And also like some of the specimens, depending on the virgin binder used in the mix, may suffer some like distortion issues during the aging process. So that because of those issues, the asphalt research community have started looking into like alternative approach, which is using loose mix aging rather than compacted specimen aging. The loose mix aging has advantages, mainly like to address those limitations that I just mentioned. Another benefit about the loose mix aging is that it allows us to accelerate, the speed of aging, if you will, within the same within kind of like in order to achieve the same level of aging. So because of that, different loose mix aging procedure has been developed, but unfortunately, like most of those procedures do not have good lab to field aging correlations, mainly because like in order to do the correlation, you need a lot of field performance data, and that takes time. If the aging procedure developed in the lab is only a few years old, you're not gonna have too much long-term performance data to really look into the field correlation. So that's why like those are the limitations or the knowledge gaps that we recognize, and then we propose this study with the objective being like to validate, the potential loose mix aging procedures with a wide range of field projects to use in a balanced mix design framework. I want to mention like this is a project that we started a few years ago as kind of like a phase 1 effort. In the phase 1 part of the project, we started a very comprehensive literature review to kind of like identify what has been done on the existing loose mix aging procedures in the research community. And then we did a critical review on those procedures to identify the knowledge gaps. What are the hurdles that, our industry or our community need to overcome in order to, get to the point that we can successfully and practically implement them into balanced mix design for state highway agencies and the industry. And then after that, we come up with a work plan to address those major knowledge gaps that we think are worth investigating. For those of you who are interested, the phase 1 report is is already available on the NRRA website. It does provide lots of good background information about what have been done in the past and what we think need to be done in the future to advance the existing body of knowledge on this topic. Phase 2 started about a year ago. For phase 2, what we decided to focus on is really to look into what we call like the conversion of different loose mix agent at different aging temperatures. And I'll explain why we think that is important. A few years ago, NCHRP 954 was completed. That was a great research project conducted by Dr. Richard Kim and his team at North Carolina State University. And through that project, they recommended loose mix aging at 95C to really address the long-term aging effects for performance testing of asphalt mixtures. Based on our critical review of that procedure, that is the most robust aging procedures in terms of the field validation because they were able to incorporate over like 35 different asphalt mixtures from like 10 field projects across the United States. So they have lots of actual like field aging data and then tie back to what they developed in the lab. So that really provides a linkage between lab aging versus the field aging. But one issue with that procedure or limitation with that procedure is sometimes it requires like a long duration. It's really depending on kind of like where you are. In some cases, it could require you to age the mixes for like, over a week. Once again, I mentioned like for 5 days, it's challenging. And then, let alone we're talking about 7 days or even longer. So it makes it a little bit challenging to incorporate into like a balanced mix design, especially during the kind of like a production type of efforts. Because of that, in the meantime, several researchers have started looking into like what we call like accelerated aging procedures. In this case, we know like aging is a fundamental like thermodynamic process. In order to achieve the same level of aging, we can increase temperature to reduce the time, right? So that's where like, the methodology came along to look into like a higher temperature. Instead of just doing 95C, we look into somewhere between like 100 to goes all the way to 135. And last year, a new AASHTO standard came out. It's referred to as AASHTO R121. This is the latest guidance from AASHTO on how to handle long-term aging for asphalt mixtures. The 95C aging that I mentioned from the NCHRP project is referred to as method C. Some of the two accelerated aging procedures listed on my slides are referred to as method D and E. So for those of you who are interested, you may want to check those out to find out more information. But like I said, some of the aging procedure, especially like method D and E, they do not have enough like long-term field performance data to do the validation. Okay, so those are the kind of like the challenges to implement them into balanced mix design. So that's where like the research team, we said like, hey, maybe there's a way that we can leverage the connection between the reference aging procedure and the accelerated aging procedure using, agent kinetics model. What I'm showing here is just kind of like the basic equation that try to predict how binder stiffness evolve as a function of aging. Okay, it is a very significant advancement on the aging research. But one thing we recognize by looking into that is that we know like binder stiffness matters in terms of the cracking resistance, but it is not the only factor that can indicate the cracking resistance. Because the relaxation properties of the binder could also affect mixture cracking resistance. So only using binder stiffness may not be sufficient to really establish that correlation, but we can use that as a starting point and then recalibrate or readjust, that model to make it more suitable for like a cracking resistant evaluation. So with that being said, we come up with a game plan to look into like 15 plant produced mixtures covering very different type of raw materials, including virgin binder grade, virgin binder source, virgin aggregate type, use of recycled materials and additives. Curt mentioned about, the additive group experiment at the main road and on the NCAT test track. We have been trying to look into like recycled plastic, rubber, fiber, and also with the more interest in using RAP and RAS as a recycling agent, just going to become more and more popular. So we were able to incorporate all those components, if you will, into the game plan. And for each of the mixtures, we propose doing like the ideal CT and the DCT under different aging conditions. So it's a fairly, comprehensive testing plan. For the interest of time for this presentation, I'm not going to go through all the detailed results, but this is kind of like one of the most significant findings that we have accomplished so far. On the left side is what we call like a method C versus method D. So this is where like you try to convert loose mix aging at 95C to like a 20-hour aging at somewhere between like 100 to 125 degrees C. So the blue curve is what we established based on the aging kinetics model using the G-star, the binder stiffness parameter. The orange curve is what we established using the mixture ideal CT data collected in this study. As I mentioned, binder stiffness matters, but it is not the only parameter, and that's why like it's a little bit like a shift, on the correlation. And then we did the same thing on the other side, trying to look into the conversion between 95C and 135C. And overall, we are very pleased with the data. Because like they definitely shows a very consistent trend showing the applicability of these aging conversion relationships moving forward. So, how does that, be used in terms of implementation into a balanced mix design framework? I mean, this is just our idea at this point for, a given agency, state highway agency, or, the non-state agencies. If they want to incorporate aging into the BMD framework for cracking evaluation, the first step they need to do is to define the target field aging. Okay, are you interested in simulating, let's say like 4 years, 6 years, or 8 years of aging in the surface on the pavement, right? You need to define that. And then you go to the 95C aging maps to determine what is the required aging duration for that procedure, okay? And then this is just kind of like a snapshot of one of the map came out from the NCHRP projects. Depending on where you are, the duration may vary from like 1 day to like over 7 days. And this is where the engineers from the DOT or from the agency need to decide, whether or not that duration is feasible and practical. If it is 1 day, maybe it is, but if it is 7 days, it can be a little bit challenging. And in that case, what this project provide is that give you an alternative. You can leverage the aging conversion relationship we established here to allow you to use an accelerated aging procedure that can give you the same, quote, quote, aging level for, BMD cracking evaluation. So it's really more about to facilitate, the incorporation of aging into the balanced mix design framework. The other thing we have been looking into, it's kind of like the aging susceptibility concept. We talk a lot about the additives. In most cases, they do have some performance improvement on the cracking side or on the rotting side. But the other thing that is important to be considered is how do those additives affect the aging susceptibility of the mixtures? Because at the end of the day, the performance of the pavement in the field is not only determined by the quality of the mix leaving the asphalt plant. It's more about how those properties evolve over time in the field. So considering aging is important, and this data allow us to look into the impact of different additives on aging susceptibility. So we have been very excited about the project and definitely appreciate the sponsorship of NRRA for this study. And we'll be happy to share more information or answer any questions through email, or if there's any short questions right now, I'll be happy to take some. So.
Thank you very much, Fan. That was excellent. Any questions for Fan? Just got a couple minutes is all.
Yeah, you got a lot there, Fan, and thanks for sharing that. I think it'd be really interesting to kind of look at each of our states too, and how does that impact us, or what's your thoughts on that? Maybe at a future meeting or something like that.
Yep,
kind of break
absolutely.
it down for us. But again, thank you for everyone who's presented today and all your participation in the NRRA. We should get going now since our time is up. But again, have a good rest of your day and a good weekend. Take care, everyone.
Yeah.
All
Thank
right.
you.
Thanks, everyone.
Thanks, Van. Really appreciate it.
Yes, sir.